Everyone, this is part two of our space industry roundtable discussion. If you've not checked out part one yet, I would recommend you do that first, but if not, enjoy part two.
SpaceX is the dominant player in so many things space. They can do what they're so far ahead. Their valuation in the private markets is around 100 billion. But Matt and I really like Rocket Lab, for example, because it's publicly traded into 6.5 billion. So it's like a market cap that's like 1/18th the size of SpaceX. And even though it's a distant second, maybe we feel like it's likely to be a clear second place to SpaceX for a long time in a lot of services. And SpaceX's primary purpose, as we've talked about before, is colonizing Mars and developing technology and making money along the way. But there will be lots of breadcrumbs, so to speak, for other companies to pick up on. And, Rocket Lab maybe has its own unique differences. One of them is launching from New Zealand. It seems like they have some kind of advantage in terms of cadence of launches, right? Are you guys familiar with that?
They do. No one's competing in New Zealand with them. They're not dealing with the ZAA telling them, oh, you can't, you can only do five. They've got the New Zealand government saying, please put us on the map, launch what you want. The same with Canada. That's why I think Space Right has a good option. Now, Rocket Lab is opening a launch center on the eastern coast of the United States, Wallops in Virginia, I believe. And now they are, Rocket Lab has succeeded. Unless they do something totally stupid, they're going to do very well. The other company, and this is my personal opinion, the other company that I think is absolutely going to succeed is Astra. And I'll tell you why. Astra has United States Air Force backing. Why? Why do they have that backing? What was the competition they competed for that no one actually made? The Air Force wants to be able to launch one rocket after another, like a day apart, a whole bunch of rockets, small rockets, putting up small satellites. Now, usually when the Air Force launches something, that's a SpaceX mission, that's hunting 10 tons, 15 tons, something massive. Because in case of an EMP attack, or Kessler syndrome, you've got to replace your satellites as fast as possible or you can't communicate. And modern government and especially warfare depends upon satellite communications. So where is Astra launching from? Where are they stationed in? Alaska. They're launching polar. So you're getting satellites into polar orbit with a small rocket fast. So they have backers wanting them to succeed, and they have a customer ready to go. So I don't have any doubt that Astra, will succeed. Now, will they become a massive company, or will they just? They will succeed. They will be worth much more than they are now. Because once you get something into orbit, then everybody says, okay, now you get your contract. SpaceX came this close to not being able to get that final rocket into orbit. In which case, Elon would have been broke. He would have spent all of his PayPal money, and that would have been it. But he did get to orbit. Now, Astra's in a better situation than some of the other small rocket companies. We didn't talk about Relativity Aerospace. They do the 3D printing of rockets. They're working on the Terran R, Terranr. No association with the Academy. The Terran R is a 3D printed mini Starship, right? It plans to save the second stage also, to launch and go up. Very interesting. They're going to be also using methane. And so they're a company to watch also. Relativity Space has the potential to make tanks, propellant tanks, much more cheaply than anybody else can. These things are outrageously expensive. When you start looking at rocket stuff and you say, hey, I need an oxygen tank with a methane tank and a common dome, can you make me one of those? Sure, $10 million. You're saying, wait, it's just a tank. It's just a metal tank. But if there's any defects in it, when that thing launches and, it's going G-forces, maybe 1.7 Gs, then if there's any defects and something bulges and breaks, just like the SpaceX rocket was going up and there was a brace holding a helium tank. And that brace was not made to specifications. They had subcontracted out, and that brace was substandard. It collapsed. The helium tank fell, exploded when it hit, and blew that rocket apart. So the satellite's gone, the rocket's gone, SpaceX looks bad, and I guarantee you they started making their own braces or they bought a company that makes braces and put someone there to stand like this and watch the assembly line, because you do not want to lose something like that because someone was being lazy or cheap. You paid them good money for that product, and they didn't sell you what they said they would. That's a big deal. So vertical integration is absolutely essential to succeeding in space, because you can't afford. Now, ULA does. The SLS is completely subcontracted out. They're like 100 companies from 20 different countries have contributed to this rocket. I'm like, that's great. There's profit added on profit added on profit.
Yeah.
You're buying a $20 tool and paying $1,000 for it because it passed through so many hands. So the companies that vertically integrate, that build their own stuff, are the ones that have the opportunity to succeed long term. Now, Rocket Lab is a success, and I think will continue to be a success. I think Astra will also be a success. Now, Relativity Space, yes, they will be a success because they print stuff for other people. They've already got a huge number of orders to print other people's stuff, right? If the current satellite companies, they say, hey, you can 3D print me a tank cheaper than these guys make it, 3D print me one, right? So they're getting their tanks, and then somebody else wants a rocket nozzle. Providing those components and 3D printing them so that if there's a change or an iteration, it's a software thing and it starts printing the new version. You're not changing all your tools and die and all that. That is the future. Only in space is 3D printing metal really worthwhile, right? I could take a 3D printer and 3D print hammers, and I'm going to go broke really quick because the cost of my 3D printer, and then I've got to have they have an aluminum alloy. They also have steel. It's basically a TIG welder, right? It's a wire-fed TIG welder, basically. And they're arcing and welding that metal as they go. So they have a proprietary alloy of aluminum with, is it strontium? I think there's a small amount of strontium in it. It's something like that. It's a metal where I would have said, why are they doing? There's a good reason why they're doing it, I promise you. It either keeps it from sticking, or there's some reason they're doing it. But they have a proprietary alloy. So Relativity Aerospace, making the Terran R. Now, whether the Terran R will be a success or not, the company will be a success. Right? Because
the Terran R is a build on top of their Terran 1, right? Isn't their Terran 1 their kind of Pathfinder vehicle?
It is. I think it's carbon fiber, non-reusable. Well, it's not. The exterior is carbon fiber. The tanks are metal. They're printing the aluminum tanks, and then they're going to cover it with carbon fiber. So the Terran 1 is a small rocket, probably about the size of the Astra 3.0, and it's, they're going to test it and fly it. But basically, since they already build a lot of rocket parts for other people, they can just throw a rocket together and try to get their own rocket going. So, and that's how you make money when you've got customers for every component of when you're getting paid to make what you need to do your dream, right? So if your dream is colonizing Mars, nobody's got that money. If you add the top 10 billionaires in the world, nobody's got that money. But once you get Starlink up and going, and you're looking at about 30 billion in gross income per year from Starlink, because it's incredible how much that will make. Now you're talking about some real money to do some really interesting stuff.
Yeah.
And the Kuiper, Blue Origin saying they're going to compete with Starlink and then suing to keep Starlink from going up. No one's going to compete directly with Starlink. You better plan something else, because they build the rockets, they reuse them. Once they've reused them 5 times, it's free, basically.
Yeah.
And the things can be used up to 10 times. So they've got 4 more flights that cost them almost nothing. I did an analysis of OneWeb and the other companies that had tried to do this before and failed because the launch costs are so high. But SpaceX is getting paid to launch stuff for the American government, for other commercial interests, and then they launch their own stuff as an extra. You're not going to compete with that. You're not going to. Now, there's other room for stuff up there. Little constellations that do something unique. But as far as worldwide internet, it's going to be here very soon, and it's going to be through Starlink. And if Amazon wants to compete with Project Kuiper, they better really get on the ball, because they have not put a single thing into orbit yet. So now, yes, the New Glenn rocket does use the engines from the New Shepard in a way. So the BE-3 that's used on the New Shepard is modified into a BE-3U and is used on the second stage of the New Glenn. So they are applying that. But it's not like they built a second stage and they're going to put that on the first stage and there they go. But they do have some engine technology. But realistically, nothing they're doing with the BE-3U is more innovative than the J2 and the J2X that were already flying 50 years ago. Matter of fact, the RL-10 is a hydrogen rocket engine with the highest efficiency of any rocket engine ever, 465.5 seconds. Nothing has beat that. The space shuttle main engines don't beat that. They're 455. So our grandparents, using slide rules and a lathe, produced stuff better than anything being done today. Now the Raptor engine is incredible, and it's the only full flow stage combustion engine that has flown, right? Because it hasn't flown in orbit, but it's flown up to 10 kilometers and all that. So it is. There's so much potential out there still.
Yeah.
And
the Raptor engine is for Starship, right? That's the main
Starship
engine.
only. I joked that Jeff should go ahead and buy a few for Vulcan, or Tori. Tori should buy a few for Vulcan and give up on the BE-4. But realistically, they're not going to do that, I don't think. But they are both methane engines.
Matt, you were saying that you were studying up a little bit on the Rutherford engine, right? For Rocket Lab. We're not experts or anything, but Matt, what were you saying about the Rutherford engine that you thought was somewhat interesting as like just a novice trying to study up on it a little?
Yeah, so I've been very curious about the space in general, and I did a little bit of a deep dive on the Raptor, and it really is amazing once you start to look into the details of what a full flow stage combustion engine cycle is and why it's been so hard and nobody's ever done it before, and then to see SpaceX actually succeed, it's kind of mind-blowing. But I realized, I tried to dive into the Rutherford engine a little bit
Electron,
more
for the
Electron. Yeah, and I didn't come across too much information about it other than, it's 3D printed, and I think one of the unique things is they've got that, turbo pump that's, electric. So I was wondering if we could just kind of tap your brains a little bit. How special is the Rutherford engine? Would it be difficult to kind of scale that up? My sense is it would be difficult to scale that up for what they're trying to do with Neutron. But just from a technical standpoint, how difficult is it? How valuable is it, the fact that they've done 3D printing, and how would you kind of rate their technical expertise with the Rutherford?
I'll start with what they're doing and why, but I'm going to let Paul answer why you really can't scale up the electric pumps.
Is it batteries?
Big size. The power requirement, right? So we're talking hundreds of thousands of horsepower. These turbo pumps are unbelievable in the power they generate. Now, the hardest thing to make in your rocket engine is your turbo pump. If you just take a hairspray can and a liquid oxygen can, and you were to spray two into a combustion chamber, you've got a rocket, right? You've got a pressure-fed rocket. That's easy. And if you use hypergolics like Russia does and China still does, and the Dragon does for its Super Draco engines, right? That's monomethyl hydrazine and nitrogen tetroxide. Then all you have to do is, you turn two valves, and when they hit, they explode. So you need pressurized tanks, two valves, and actuators, because you don't want to be standing there doing that when that goes. And you've got a combustion chamber and a nozzle, and you're good. The hardest thing to make, as you start to scale that up, you can't keep making it bigger, because you can't pressurize the tanks without them blowing apart once they get big, right? And so you've got to move the propellant. Kilograms per second determines the thrust your engine can do. The ejection velocity of the propellant times the kilograms per second, or mass, propellant flow through the engine, determines the thrust of your engine. So these turbo pumps are beautiful works of art, and that's why I think Blue Origin's having a problem with it. Now, Rocket Lab was the first to do something very innovative and look at this and say, you know what, for their weight, electric motors have the highest power for their weight in a small size. And lithium-ion batteries, or they're probably using phosphate ion or something, they're probably using a primary battery. They don't worry about it being rechargeable. They're going to throw it out of the rocket anyway. So they're using a very high power density battery, and then these electric pumps, super tunable, right? A turbo pump can only power down to about 40% before it starts kind of stuttering, and that'll blow that thing to pieces because it's going at about 40,000 RPM. So you get a little rattle going in there or something, it's gone. So the electric are super dependable, super controllable. And so they just 3D print their combustion chamber in their engine. They pump, the fuel around the nozzle and everything. And when you 3D print, you can make that all part of the design in this beautiful way that you could never do with traditional manufacturing. So you design, you 3D print it, and you hook up your oxygen, and you to the electro pump, and you connect that to the combustion chamber. You hook up your fuel and connect that, and you turn that power on, and you can step that thing up. You can adjust your oxygen fuel mixture and all that. It works beautifully. Astra also uses electric pumps, right? So other companies are starting to look at this and say, this is a smart way to go. As it gets bigger, you can't use electric pumps because the pumps don't scale up like that without getting really heavy. It'd be great if you could put like a Model 3 engine, but also the electric pumps become incapable of producing the amount of power needed with the batteries, that the mass of the batteries justifies their weight. Paul, go ahead, and you've looked at the Raptor quite a bit.
Going back to the electric pump-fed engines, I think that theoretically they say the limit is per engine roughly like 22,000 to 25,000 pounds thrust. Right now, the Rutherford puts out around 5,000 to 7,000 pounds of thrust. So you can scale it up to a certain point, but like Joe said, there comes a point when you cannot produce enough to get those higher levels of thrust. I mean, to put in perspective, some of these larger traditional engines produce millions of pounds of thrust, right?
Yeah.
But in general, the Rutherford is great for smaller launch vehicle applications. And one of the biggest things is without all that extra turbo machinery, it just makes it so much more simple. And a lot of it's just controlled by software. So it's faster to manufacture, it's less complicated. It's easier to control with software. You can control the exact fuel mixture and ratio to get the very last drop of fuel out of there. So it makes sense. It makes a lot of sense for smaller launch vehicles. You can scale it up to a certain point, but for Neutron, I think that's just beyond what they're able to do. I don't think they're going to be able to do that with a Neutron, even though energy density is improving, and that was one of the limiting factors that you guys mentioned. It's just they're gonna have to go to a more traditional engine, which will be really interesting when they announce Neutron, what type of engine they choose to go with. And I know they're really focused on reusability and not having really long refurb times. So it'd be interesting to see how they're able to refurb it very, very quickly so they can launch right again.
Now, how you power your turbo pump, there's variations in that also. There's expander cycle, where you run the fuel around the nozzle and the combustion chamber so it heats up. You use that now heated gas to power your turbo pump. And that's how the Blue Origin BE3U, it's an expander cycle engine. This only works with methane and hydrogen. It won't work with RP1, and it doesn't work with hypergolics, of course, because they don't expand enough to produce enough power to keep your turbo pump powered up and spinning. So with methane, you can make, and the European Union is making an M10, which is an expander cycle methane engine, right? Now, you can spin your turbo pump with the expanded gas, so it's expander cycle. You can have a pre-burner that burns like it's a little combustion chamber. It burns and produces hot gas to spin the turbo pump, and then dumps it off the side, right? That's what the Merlin engine does, right? In the Falcon 9, it's burning RP1 and just throwing it out, right? That's what the F1 engines on the Saturn V did. You can try to pump that back in to save that, but then you're creating high pressure here, and then you're trying to stuff that. Now it's low pressure gas after it's run your turbo pump. You're trying to stuff it into a high pressure combustion chamber. It hasn't worked out to be, the perfect option. Then there's burning fuel rich, the way the Space Shuttle main engine did. It had one engine burning fuel rich, one pump burning fuel rich, I should say. And the Soviets had perfected that technology, and that's what the RD-180 does. That's what the Blue Origin BE-4 does. The Starship Raptor is totally different. The turbo pumps are run by putting a little bit of oxygen in the fuel turbo pump, and a little bit of fuel in the oxygen turbo pump, and spinning them in these giant tubes so that the entire propellant is going through the entire system and then dumping into the Raptor. And that's why the Raptor is much smaller than the BE-4. It puts out almost the same power, just a little bit less. The BE-4 is, the engine and turbo pump and everything itself is probably 3 times the size of the Raptor.
Yeah, the engines are really the heart of a rocket, and I mean, Elon's a goat for many reasons, but one of them is when he started SpaceX. I mean, he was focused already early on the Merlin engine development, and the Merlin engine, they use a single Merlin for the Falcon 1, and then that flowed in. He was already thinking about bigger launch vehicles, and they ended up using 9 of those, for the first stage of the Falcon 9, 1 for the second stage. So since 2002, they're developing the Merlin engine. At first, I think flew 2006, and then they haven't even had an orbital test yet with the Raptor engine. So pretty much all of SpaceX's history is with the Merlin engine, and they've been able to use that engine and scale it up to larger and larger launch vehicles. That would have been amazing to see, Rocket Lab or some of these other competitors do something similar. Unfortunately, because they use the electric pump turbo engines, they're going to need to come up with a new engine for their larger launch vehicles, which will be very interesting to see what they choose.
Isn't there something like 25 Raptor engines on the Starship or something? How many is it? Are they putting on?
29 right now, with the plan of 32 later, and they're up to 1,300 kilonewtons of thrust, which is just mind-boggling. It will be the first thing to leave the ground more powerful than the N1 and the Saturn V. Now, the N1 left the ground; it just didn't leave the atmosphere. It did leave the ground. So what they've been able to accomplish, and if you just look at the Merlin engine. So Elon's genius is finding the right people and giving them the freedom to create, right? So he said, "Who's the best rocket engineer out there?" Whatever. And people are saying, "Oh, this Mueller guy's brilliant," but he's given up because he's out making model rockets out in the desert. So he goes out to Mueller and says, "What would it take? If you could build the engine of your dreams, what would it be?" All right, I've got 130 million. And they come back, they start working on the thing, and he makes the highest thrust to weight ratio engine ever. Pretty much the perfect RP1 engine is the Merlin. I mean, it's hard to see where you're going to squeeze better performance out of that. And then it relights and it's reusable, and they, now the thing's landing back, and they've done things no one thought was possible because he found the right person and set them loose. If you're working for Boeing, and I have a good friend who does, or who did, he saw the writing on the wall. The 737 MAX, he said,
Ooh,
so
yeah.
He got out just in time because then there were a bunch of them looking for jobs. If you'd worked for Boeing, they would stifle you. I have this great idea. Okay, well, submit it to your sub manager, and he will submit it to the manager, who will submit it to the to the hyper manager, who will submit it. It's you might as well not even try. Elon Musk will fire somebody if they get onto somebody for jumping over what is not a chain of command to go straight to him with a good idea, right? You can go straight to Elon Musk. If you work for SpaceX, you can be on the assembly line and you say, "Hey, this tool's stupid. There's a better one." You can send Elon an email, and you don't get fired for it. Try that at Boeing. Send Tori an email and see what happens to you. It is that kind of innovation, that kind of freedom, that I think makes SpaceX so unique. Because these people are doing it because they love what they're doing, right? Hardly anyone goes into the space industry because that they want to be the richest man in the world. That's almost an accident and timing. Because
Yeah.
the old joke used to be the fastest way to become a millionaire in the space industry is start a billionaire, right?
Yeah.
Yeah.
Because there were all these guys who well, Blue Origin is using a launch site, a test facility in Texas, built by a guy who lost millions in the space industry. What was the name of that guy, Paul? He built an engine, a really nice engine. He presented it to NASA, and they said, "Nah, we don't want to fund it." And he abandoned the complex, and then Blue Origin bought it from him. Oh, I'm terrible with names. I will look it up and get it to you. But he had started with maybe $300-400 million and thought that would be enough. And when he got down to 100 million, he decided, you know what? I'm not going to keep doing this. That's expensive. Elon was willing to risk it all, but he also gave people the freedom to create. And the Merlin rocket engine, though the Raptor gets all the attention, the Merlin rocket engine is a work of art. It is a beautiful technical achievement.
Yeah, Tom Mueller is a propulsion god.
Yeah, and it's that type of innovation, and no one would have known that had Mueller been stuck out in the desert making model rockets. Because no one would let him build what he wanted to, and he didn't like working for stupid people.
Yeah.
So I don't mean to be rude to anybody he worked for, but seriously, if they put a manager in charge who knows nothing about rockets, and I think that's one of the differences between Blue Origin and SpaceX. Elon started as a physicist and taught himself rocket science. Now, people can say, oh, he's self-taught. There's nothing wrong with being self-taught. The most important things in our life are always self-taught.
Yeah.
We go to school so that we have some guidance in how to self-teach ourselves. But with Blue Origin, you've got a guy who did not teach himself rocket science in charge of making the decisions. So the engineers feel stifled, and they get an opportunity to go over to SpaceX, and they say, guess what? We're going over. You've held up, the moon launch for 7 months with this goofy lawsuit, and we're going to go over and work for SpaceX. Yeah. So that's the difference. One of the differences between SpaceX and Blue Origin. Now, I think Beck, I think he loves space. He dreams space, right? If you dream space and you've got the technical savvy, you can succeed. You just want to be in the space industry. I'm going to make things to make money. Photon, everyone's saying, well, how sexy is a satellite bus? You've got Elon throwing, 5-story chunks of steel into the air, and you're talking about a little photon rocket. That thing's going to Mars and Venus. It is going to be an interplanetary spaceship. So there are thousands of ways to succeed in the space industry that people don't immediately think of, that are going to, all these slots are going to have to be filled. Even things like the spacesuits. SpaceX was already working on spacesuits before they even have anybody going anywhere in space, right? Yeah. So when it's time to do it, we got one. It looks better than anything that's ever been made before. It's not this orange pumpkin suit thing,
Yeah.
So if you do go down, you're going to look good. So, it
looks a lot more comfortable. That's for sure.
It is. There is a functionality. There is a beauty to something being functional. And that's what, SpaceX and even Tesla, you can see that aesthetic in almost everything they do.
Yeah.
Functional above all else. It has to do what it's supposed to do.
Yeah.
Just about better than anything else, and excellent no matter what. And then simple. The best device is no device. They're not going to have, they're talking about the Starship, how they're going to do the separation. They said, just start the booster into a flip back and then, release it.
Yeah.
It's going to flip. It's forces are going to push them apart. We're not going to have giant springs throwing the thing out. We're not going to have little rockets pushing it forward. Simple like that, something simple like that, where the laws of physics are on your side is a really good way to make sure something works. Now, the neutron rocket, they're going to have to make a turbopump. Going to have to, and that is the hardest thing to do in a rocket engine. Everything is hard, but the turbopump is, I think Paul would agree, is the hardest thing to do.
Yeah, I mean, when you're looking at good investments too, we touched on a couple of things here, but these founder-led companies like Elon Musk, like Peter Beck, where they've been working on rockets for 2 decades, right? Peter was melting sinks back in the day using hydrogen peroxide as a propulsion option, when he's like a teenager. That's what you want, right? You want someone. There is risk, right? Where the main guy, if something does unfortunately happen to them, that is a risk to the company. But at the same time, when you have someone that can talk to every person, all the engineers, all the manufacturers, and they're making the decisions, that helps a lot. When you have something like, I think the Virgin Galactic guy, didn't he just come from Disney or something? Like he was like one of the Disney CEOs. I mean, that's in my mind, that's not ideal, right?
Yeah.
Like an MBA in charge of a space company or something. Yeah.
Yeah, and then also looking at capital expenditures, like one thing that we look at when we're looking at relativity space or Virgin orbit, we want to see how much it costs them to get to orbit, right? That's a good kind of apples to apples comparison. And you look at SpaceX, I think they spent just over $100 million or so for Falcon 1 to get to orbit. Rocket Lab was down there as well, I think around 100 million or so mark. But you see, like Virgin Orbit, I think they spent near 750 million to get to orbit, and their headcount's much higher. To me, as an investor, that's a huge red flag, right? If they were to merge with the SPAC and go public, I mean, if you spent 7x what your competitor did to do the same thing with a launch vehicle that's dropped off from an airplane that's not scalable to a larger vehicle, I mean, there's a lot of red flags there, right?
Yeah.
I think Peter Beck's focus on efficiency is one of the things that is super attractive to me as well. I mean, I think he doesn't really get enough credit for, his capability as a CEO. Maybe he's just not as well known as Elon. Well, he clearly is not, but he clearly understands the technical side like very well. He's well engrossed in all of those decisions. But he also has what you want to see as an investor, just kind of the focus on efficiency. How can we get there cheaper, faster, better? I mean, he's got this insane focus on, we need to do things quicker. And it really reminds me a lot of what you see out of Elon. And it's not just a show. I think, Trevor, you mentioned from Nikola Motors, love to kind of compare himself to Elon, probably just to stroke his own ego. But what you see with Peter Beck is he doesn't compare himself to Elon. He's very mild-mannered, but he's got this, just inner desire, focus on efficiency. I mean, if you look at, I'm a kind of financial statement nerd, and I love just looking at how low their expenditures are on O&M and on capital to do the things that they've done, and it's really impressive. So then you start fast forwarding 5-10 years. And you look at what SpaceX is probably going to be doing, focusing on building a colony in Mars, largely funded by this internet constellation. But Peter Beck's focus, I think their actual motto is we open access to life on Earth. So, I think you look 10 years forward and say, okay, where's this whole industry going to be? Clearly SpaceX is going to be focusing almost all their resources on Mars colonization. And to me, that leaves the door open for another player in Rocket Lab. Seems like they're the clear one to my mind, to really go after agricultural applications on Earth and 3D printing, in low Earth orbit, and not to mention these other applications.
Services.
Other constellations. So me as an investor, seeing kind of like a mini Elon who can do all these things, has the capability, has the business acumen to pull it off, has this kind of burning drive and desire. I love it. And I just see the potential from a company that's only valued at $6.5 billion. Just seems like a huge winner in my mind. So it's been a bit of a rant more than anything, but I'm curious if you guys see anything different, any holes in that thesis, or what do you think?
Well, it's not just Peter Beck too. It's Adam Spice as well, right? The CFO. And I think one of their mottos is like ruthlessly capital efficient. Yeah. Where they I mean, that's a great motto, right? Where they literally focus so much on their costs and keeping them in control, under control. That's what you want to see. And when it comes to speed and urgency, I think there was an interview where Peter Beck was talking about how they recovered the first stage Electron, and they tore into the heat shield and made improvements to future heat shields, and it took them like 3 or 4 months. And he was commenting that was way too slow. They needed to go faster. But when you look at traditional, how much time it would take like a traditional rocket manufacturer, that was like an order of magnitude faster. I mean, so but the CEO is so hungry. Peter Beck, no, that was too slow. We have to go faster, and that's what you want to see.
Yeah,
That's
with
the
the traditional companies, you'd have 3 months just to schedule a meeting with all the right people in the room, and it's like
Then there's a
so
committee that has to
infuriating.
look into it. Yeah.
That's the difference between old space and new space.
Hmm.
To think that you can give a company like Boeing even $1 billion and not have something in the air tells me they're doing something horribly wrong. Same thing with Blue Origin. If you look at how much they've spent, Virgin Galactic, same thing. So who did Blue Origin and Virgin Galactic hire? Ex-NASA people, ex-Boeing people, ex-old space people. Old space is subcontract everything. Money doesn't matter. It's all from the taxpayers. America's the wealthiest nation on earth. It's partially defense spending or whatever. You can get a contract. Boeing got a contract for $250 million and did nothing with it. Nothing went in the air. They were looking at a space plane. So they looked at it.
Wow.
And said, oh, your 250's gone. You know, if you actually want us to build something, it's going to cost even more. If you had given Lynx Aerospace, not $250 million, but $25 million, you'd have something going up and coming down, I guarantee you. And that's the difference. And Beck is a very good example of that. And he, you know, he doesn't compare himself to Elon Musk, but he does have the Albert Einstein thing going on with the hair, which I fully support.
The accent is great too. I really like the accent.
It is.
Yeah.
The wattage of the brain power is causing his hair to just like being on a Tesla coil. He's a brilliant guy, and he's got a dream, and that dream is to do space stuff. And the only way you can do space stuff is by not wasting your money, or you will go broke. So the old space industry, you know, Richard Branson thinks he's rich, and till he starts trying to put things into orbit. And as you know, Paul said, $750 million to put Launcher 1 up. Look up the Pegasus rocket system. Pegasus rocket was carried up by a B-52 and launched decades ago. Launcher 1 is not something new. Mm-hmm. So he spent $750 million doing something that he could have paid a heck of a lot less. He could have bought a B-52, refurbished it, bought several Pegasus rockets, and bang, you'd have had this stuff in orbit. So is your goal to advance humanity into space? Or is your goal just to fly up in your rocket plane and have your own rocket plane with Virgin Galactic on the outside, right? Elon Musk, it is his goal to colonize space. In order to do that, all these other things have to fall in place. So he's making all those things happen. For Beck, it's his dream to do stuff in space. In order to do that, to have his rocket company, he can't go broke. He's not a billionaire. He doesn't have billions to waste. So when you give him $1, that dollar is going to be squeezed, and he's going to find the cheapest way to make something that works and get it done. And he's just now getting to have a little freedom. You know, he had said they wouldn't be reusable and they wouldn't try a bigger rocket because it did not seem feasible when he started. But after he started making some, you know, now that they're succeeding and they're selling enough of their components and their launches, he's saying now we can. You know, now we've got enough coming in, enough investment coming in that we can step out and go for something bigger. But old space, give us billions and we might at some point get something off the ground. New space, we're going to squeeze everything we can out of every dollar you give us. And if we don't get something into space, we completely failed. You know, we are complete failures as human beings. So, and the people behind the scenes, I mentioned Space Ride out of Canada. Mm-hmm. The chief operating officer is a very brilliant businesswoman. Having that combination of the technical savvy, which is Saurabh Hagigat, and the financial management, that's what will help something succeed, right? Because you've got to have somebody. Well, I don't think SpaceX would be where it was without Shockwell. I don't. Gwen Shockwell.
Yeah, she's been a big part of their execution.
Huge, and her going to smooth things over with the contracts, because you know Elon's not the most people friendly person. You know,
look at him with Hertz. Like how he's communicating the Hertz deal with Tesla.
He was talking to an Air Force general, and the general's sitting there, and Elon says, "You know, in a decade there won't be pilots in aircraft." And the general's saying, "Oh my God, I'm a pilot! You know, I've got all these guys training." Yeah. But Elon's right, but that might not have been the most opportune time to bring that up.
Yeah,
you know, it's 20 years from now, we'll all be cowering on our corners while the Boston Dynamic robots fight it out. And then they'll come tell us who won, you know.
It'll be the Tesla bot robots by then.
Exactly. It'll be you guys won. Yay. And we can come out because no human being will compete with a robot on the battlefield in a decade.
Yeah,
No
I
human
believe that.
Right?
Or
So-
in space, maybe. Yeah.
Same thing. Now, what can the Tesla bot do? The Tesla bot can be remotely controlled to work on the moon. Right? You can have humanoid robots testing all your systems on the moon and mining on the moon operated from Earth. The delay is not long enough to make it impractical. So humanoid robots for places where you're going to send humans, let them work the airlock several times, and if it fails and blows him out the airlock, we're all sad. But nobody, we can put him back together. You can't do that with people. So I think there's so many things that, just Neuralink blows my mind. The whole Dojo, computer system.
Yeah.
Those are space applications that he's taking, whereas, these things went from NASA, from the Apollo program out to industry and eventually, to commercial use. SpaceX is doing it. SpaceX and Tesla are kind of doing it on their own. They're making these applications, but they're big enough to do that. But SpaceX is leaving a lot of money on the table because they're launching big stuff. And the future is not just big stuff. There'll be
Small stuff.
Exactly. A lot more small
Satellites
stuff.
are getting smaller. Yep.
Nano satellites are now just ridiculously small.
Yeah.
Things about the size of a baseball, and it can actually do something productive and make money out there.
It's crazy.
So small rockets absolutely have a future.
Yeah. Well, this has been a great chat. We've gone on for a long time. Really appreciate all your time, Paul and Joseph. And I don't know, Matt, do you have any kind of closing questions or anything for either of them before we ask if they have any closing thoughts about anything?
No, this has been incredibly helpful. I mean, a lot of what we're trying to do on this channel is really just kind of open source our own research, and I think having conversations like this is just really helpful in doing that. So I just thank you guys so much for your time.
Yeah.
It was a pleasure. I appreciate the opportunity to chat with you, gentlemen.
Yeah.
Yeah, it's been awesome. And yeah, I mean, to kind of summarize, I think SpaceX by far in the lead. Behind them, Rocket Lab is based on execution. No one is in second place but Rocket Lab at the moment. Behind them, I think Astra is something to consider, but they're still maybe a few years behind Rocket Lab, but still a very interesting choice. And they have a great team in place. They are focused on very low-cost launch vehicles that are very cheap. And Relativity Space is something to watch for as well because they're doing 3D printing for pretty much the entire rocket. If they can pull that off, that can be a huge game changer. And then, but TBD, right? They haven't launched Terran 1 yet. So keep an eye on them. Keep an eye on Blue Origin if they can do something with the New Glenn, which has been postponed. And that's a big if still in my mind because they spent so much money. Their head count is so high at Blue Origin and, TBD on that.
I feel like Blue Origin is like the Rivian of the space industry or something. It's like, it's got a lot of hype, a lot of publicity, but it's got a long road ahead of itself to really be successful for the hype it's drawn up.
The production facilities, how many Tesla killers have popped up? The Porsche Taycan's going to what? Where you don't have superchargers, you don't have the thing costs 5 times more. I would also draw your attention to Firefly Aerospace. They are, I think, going to make their next launch, and they do have a very smart team. And then Space Ride has not gone public. They're doing a private investing right now, and that can be a good opportunity to get in on the ground floor. But I think they have they're going to get 150 kilograms to orbit for $1 million or less.
Wow.
And,
Joseph, are you worried at all with the Firefly previously going bankrupt before they reincorporated? I've
done some research into that, and it was, quite often when you split from a big company and start your own thing that directly competes with that company, you're going to get sued. We can't forget that Nikola sued Tesla, claiming that Tesla had stolen their technology. But the founder of Firefly had worked for Virgin Galactic Virgin Galactic, said that he had taken some of the carbon fiber secrets and whatever and sued and actually won. It was by arbitration. It wasn't a courtroom, so there wasn't really evidence presented, and that forced them into bankruptcy. They were bought out by kind of an angel investor from Europe. I believe he had some kind of a dating site that had made him a billionaire and wanted a rocket company. They have since kind of gotten on track and have been doing really well. And of course, the Alpha rocket, besides one engine out failure, came very, very close to getting to orbit the other day. So I think they will succeed. Now they're succeeding at getting to orbit and succeeding long term as a rocket company. Rocket Lab is the only company that I think has succeeded, is past the hurdle where they have to do something to fail. Otherwise, they're on a good coast. They're doing really well. Every other company we're talking about, Firefly, Astra, Relativity, they're all still climbing that hill. They have not gotten over the top. When you can reliably and dependably get something to orbit, you have the potential to succeed. That's very different from actually succeeding. So Rocket Lab, in my view, has succeeded.
Yeah, those three companies, Firefly, Relativity Space, and Astra, I mean, they all have launch attempts coming up. So it'll be interesting to see, sit down in like a year from now and see who made it and who is falling short, because
maybe we're gonna have this discussion again in a year, next Veterans Day, and talk further about stuff. Yeah.
There's room for all three. There's a lot of room on the small end. There's not that much room on the big end. So New Glenn better get on the ball, because they, if they're not flying soon, Starship's going to make them obsolete. The Ariane 6 will be obsolete before it ever fires a single engine. And that's sad, because, the Europeans are spending billions on this giant rocket. But I am fairly confident that Starship is going to work, and that Musk has enough resources right now that he won't stop till it does work. And the minute it sends something into orbit, the Russian Angora, the Long March, is it 9 out of China, the Ariane 6, all obsolete. The Vulcan, pretty much obsolete.
Do you think SLS is already obsolete?
It is. It is. The minute it flies, they're just burning money. They may as well just take a big pit and throw money in and watch it burn, and at least you get some thermal energy from it. And you can warm your hands over it. I loved the concept, and had they built it and flown it within 6 years, like the Apollo program did, 63 to 69, we went from no rocket to rocket on the moon. Had SLS done that after the retirement of the space shuttle, had they got that thing off the ground within 5 to 6 years, as they easily could have. They didn't even build anything new. They took RS-25 engines and the big shuttle tank and the boosters and add another thing. It is only because of old space ineptitude and waste that thing did not fly on time. If it had flown on time, it would have been a success. It would have been an incredible success. Because you're talking about a lot of mass to the moon or to low Earth orbit. Now that type of throwaway technology has been superseded. You could argue that it wasn't possible when SLS started. But had SLS flown within 6 years, wonderful success. Everyone would have been just floored. The fact that it did not, and it has not yet flown, is a little bit like the Starliner. Even if they get that thing flying, do you really want to go on it? Do you really want to be one of the guys? No, I don't want to go on it. I'm going to go on a Dragon capsule. I love space, but I don't want to die there. It's no fun.
All right. Well, thanks for all the knowledge you guys have dropped. Matt and I certainly have learned a lot. I'm sure many people who listen to this will, and we'll make sure to put links to your channel, Joseph, Terran Space Academy, into the description, and Paul will put information on how to reach you, if that's okay, into the description if people want to ask you questions maybe. But yeah, I really appreciate all your help and helping us answer some questions on this stuff. And yeah, we look forward to seeing how things turn out, and maybe doing something like this again next year sometime, if you guys would humor us.
Absolutely. Be happy to.